Bearings are machine parts in which other parts turn or slide. They are found in almost every type of moving machinery. Since your job involves maintaining equipment that uses bearings, you need to know how bearings operate. You also need to know how to recognize the types of bearing failures that may occur, how to remove bearings, and how to install new bearings. The two general categories of bearings are rolling contact bearings and sliding surface bearings. This unit focuses on rolling contact bearings. Bearings are found in almost every type of moving machinery, and they perform three basic functions: carrying a load, reducing friction, and positioning moving machine parts. The term load refers to the force or weight that is placed on a bearing. Different bearings are designed to withstand different types of loads. The type of load that is placed on a bearing is determined by the direction in which force is applied. This force can be either axial or radial. Let's look at an illustration to see what these terms mean. Most bearings are mounted on rotating shafts. A shaft rotates around a center line or axis. The distance from the axis to the outside of the shaft is called the radius. While individual bearings may differ slightly, a typical rolling contact bearing consists of rolling elements, an inner ring, an outer ring, and a retainer. The rolling elements in a rolling contact bearing are either balls or rollers made of specially hardened steel. In this example, the rolling elements are balls, and they are set between two hardened steel rings, an inner ring and an outer ring. These rings are often called races. In a typical installation, the outer ring is fixed and doesn't move. The inner ring is fitted to the shaft. As the shaft rotates, the inner ring also rotates. The rolling elements are held in position by the retainer, which you may hear referred to as a separator or a cage. The retainer positions the rolling elements evenly around the rings and ensures that the load is distributed equally on each rolling element when the shaft is turning. In addition to these parts, some rolling contact bearings are equipped with devices that protect them from dirt and other contaminants. One type of protective device is a shield. A shield can prevent all except the very smallest contaminants from entering a bearing. The shield is usually attached to the ring that does not rotate. Another type of protective device is a seal. A seal is similar to a shield, but it has a lip that rubs against the ring that rotates. Seals are used primarily on permanently lubricated bearings because they prevent the lubricant from leaking out of the bearing. Rolling contact bearings can be divided into two categories based on the shape of their rolling elements. The two categories are ball bearings and roller bearings. The various types of ball bearings differ primarily in the shapes of their inner and outer rings. Let's look at some common types of ball bearings. This ball bearing is a shallow groove ball bearing. In a shallow groove ball bearing, the inside surfaces of both the inner and outer rings are shallow. This type of bearing is specifically designed to handle radial loads. A deep groove ball bearing is similar to a shallow groove ball bearing, except that the inside surfaces of the inner and outer rings are deep. Deep groove ball bearings are designed primarily for moderately heavy radial loads, but they can also handle a small amount of axial load. This type of bearing is also called a Conrad bearing. This is a spherical race ball bearing. It has a deep groove in its inner ring, but the surface of its outer ring is shaped like part of a sphere. This type of bearing is designed primarily for radial loads, but it can carry some axial load. Spherical race ball bearings are called self-aligning bearings because they can adjust to some misalignment. Misalignment is a condition in which one ring of a bearing is out of line with the other ring. The shape of a spherical race ball bearing allows it to handle a small amount of misalignment. Another type of ball bearing is an angular contact ball bearing. An angular contact ball bearing has a high shoulder on one side of the inner ring and a high shoulder on the opposite side of the outer ring. This design allows the bearing to handle both axial loads and radial loads. Angular contact bearings are often used in pairs so that they can support axial load in either direction. The surfaces that contact each other are specially machined to match. If one of the pair fails, both bearings must be replaced. This illustration shows the main parts of a type of ball bearing called a ball thrust bearing. In a ball thrust bearing, the inner and outer rings are parallel to each other instead of one inside the other. This placement of the rings allows the bearing to support axial load, but only a small amount of radial load. The other basic category of rolling contact bearings is roller bearings. Roller bearings can carry more load than ball bearings because rollers are larger than balls, and they spread the load over a greater area. Let's look at some common types of roller bearings. Cylindrical roller bearings have rollers that are shaped like cylinders. These bearings are designed primarily to support heavy radial loads. Needle roller bearings are similar to cylindrical bearings, but the rollers are much thinner. Needle roller bearings can support a great deal of radial load because many of the thin rollers can be put into a bearing. Needle roller bearings are often mounted without an inner ring or a retainer. Instead, the rollers ride directly on the surface of the shaft. Because these bearings can be mounted without an inner ring, they are often mounted on shafts where space is limited. Another type of roller bearing is a tapered roller bearing. In tapered roller bearings, the rollers are smaller at one end than at the other. The rings are tapered to match the rollers. Tapered roller bearings can support both radial loads and axial loads. Barrel or spherical roller bearings are self-aligning bearings. The outer ring is shaped like part of a sphere, which allows the bearing to align itself. Barrel roller bearings are designed to handle primarily radial loads, but they can also handle some axial loads. This illustration represents the construction of a roller thrust bearing. In a roller thrust bearing, the rings are parallel to each other instead of one inside the other. Roller thrust bearings are used to support heavy axial loads, but only a small amount of radial load. Bearings are precision parts, and they must be installed as precisely as possible. How the bearing fits onto a shaft and the kind of mounting that is used are both important to the proper functioning of a bearing. The term fit refers to the tightness or looseness with which a bearing is installed onto a shaft. There are two kinds of fit: push fit and press fit. A push fit is a fairly loose fit. Usually a ring that has a push fit can be pushed into place by hand. A press fit is much tighter. More effort is needed to press the ring into place. A press fit is also called an interference fit or a shrink fit. Generally, rolling contact bearings have a press fit on the ring that rotates and a push fit on the ring that doesn't rotate. In most bearings, the inner ring is the ring that rotates. So let's take a look at some methods for mounting bearings whose inner ring rotates. One inner ring mounting method that's commonly used is lock washer lock nut mounting. In this method, a shoulder on the shaft is used to prevent the bearing from sliding in one direction. The shoulder is the place on the shaft where the shaft size changes so that a bearing can be placed against it. The bearing is installed with a press fit against the shoulder. A lock washer and a lock nut are used on the other side of the bearing to prevent the bearing from sliding in the opposite direction. The lock washer has a tab that fits into a slot in the shaft and prevents the lock washer from slipping around the shaft. Other tabs on the lock washer can be bent to fit into slots in the lock nut to prevent the nut from loosening. Another method of mounting a bearing is called end plate mounting. This method is used when the bearing must be mounted on the end of a shaft. When end plate mounting is used, one side of the bearing is held in place by a shoulder on the shaft. The other side of the bearing is held in place by an end plate. This end plate is secured by locking bolts that screw onto the end of the shaft. Another method of inner ring mounting is called eccentric cam mounting. In this type of mounting, the bearing's inner ring is wider than usual. One end of the inner ring has a projection that is slightly off-center from the rest of the bearing. This projection is called an eccentric cam. A locking collar fits over the cam. The shapes of the cam and the locking collar cause the inner ring to be squeezed against the shaft when the locking collar is turned. Another type of inner ring mounting is tapered sleeve mounting. With this method, the inner ring of the bearing is not mounted directly on the shaft. Instead, a slightly tapered metal sleeve is placed on the shaft first. Then the bearing is slipped over the sleeve. The inner ring of the bearing must have a matching taper so that the ring will make full contact with the sleeve. The bearing and the sleeve are secured to the shaft with a lock nut and lock washer.